Control Flow Part 2 of 2. In this nugget, we're going to extend upon what we learned in the previous nugget when we examined the if statement and conditional logic. Here we're going to look at two other workhorses in the Python stable. First, we'll understand how to count with the for loop, and then we'll do something a little bit different. We'll evaluate a condition constantly over time by using the while loop. Each of these loop types is at the same time a little bit similar and yet has a distinct purpose in your code. Let's get to work and I'll tell you more about it. First, we have the for loop. The way I'd like you to think of the for loop in terms of just an easy introductory method of understanding is that the for loop is our counting loop. What it does is it cycles or loops through an iterable. According to Wikipedia, iteration is the act of repeating a process, usually with the aim of approaching a desired goal or target or result. You probably use the word iterate in your daily speech. I know I do. Could you reiterate your request? In other words, could you repeat the request? Now, what is an iterable? In Python, you can use pretty much any sequence type as an iterable. You can use a string, list, tuple, and even, although it's not officially a sequence, we can use a dictionary as well. So for instance, if we were to loop through a string called string, then what we're doing is cycling through looking at character by character or index position by index position through that string. If we're dealing with a list, you know we work on the basis of the element. So the for loop is going to start with the 0 index position element and then work its way from left to right. As you see here from our general syntax, the for statement is a compound statement. We open a for statement with for variable in iterable. Now this var is a name of your choosing that you declare dynamically on the fly. Historically in programming, you tend to see variable names like I, J, K, etc. There's some computer science geek history behind that we don't need to worry about. If you want to use I for your for counters, that's perfectly okay. Use whatever name makes sense to you in your program logic. So for that variable in that iterable sequence, whatever it is, colon, and then indented, we perform some kind of action. We do our loop body, and we make sure to reference the variable that we've declared here in our for statement. Now I'm going to show you a lot of examples of this so you can really get a feel for it. With for, you can get kind of complex with it. You can nest one for statement inside of another one. Typically you'll find the if and elif and else blocks inside a for loop. Pretty much any logic you need to apply to every element in an iterable, you can get that done in a for loop. For loops are also good besides just as counters. You can use them for iterating or scanning files. You might want to create some administrative automation tools to help you in your systems administration, systems management. You can use for along with, say, the open Python function that we'll look at in a little bit to open a log file on your server and read each line one after the other, and then you can do with what you want with that data. As an alternative to an iterable, you can also do a for loop in a range. The range function is awfully useful in Python. Range takes an integer sequence. You could do range 0, 5 to do a loop through 0, 1, 2, 3, 4. I think I've mentioned before that the range function does not include the terminating decimal. Shorthand notation, if you know you want to start from 0, is to just do range with the topmost non-inclusive integer. If we do range 5, for instance, again, we're going to iterate 0, 1, 2, 3, 4. Now let's open up idle, and I'll show you how this works in practice. We'll begin working from an interactive prompt here. It's fine using most compound statements from the Python shell. Ultimately and eventually we'll go to a separate external script file though. Let's lead off with a statement for letter in Python. So remember, letter is just an arbitrary Python name or Python variable that I'm declaring on the fly that's going to be used only within this for statement. The iterable in this case is a 1, 2, 3, 4, 5, 6 character string. We press enter and we get our indent by default, and I'm just going to do a print statement with a string literal space, and then I'm going to call that variable. You see how this works? So we're going to print current letter is space and then Well, why don't we just run it and I'll show you. Hit enter once, enter again to actually run it. This is a good example that shows you the iteration of the for statement. So this call to letter here goes over and over again back up to the header line, starts with P, then comes to Y, T, H, O, N. As another example, why don't we do something with a list? How about for veg in? We'll just choose 3 representative vegetables. Of course, this is a list. Use our colon to come down to the sweet area of this statement. And let's just do the same thing as we did in the previous example. We'll run a simple print statement like this. There we are. Although most of our examples here are very elementary, I want you to begin thinking, if you haven't done so already, on how you can begin to apply some of these Python statements and modalities to your real-world programming and solution development priorities. Okay? Why don't we play with the range function next? I'll say for I in range, and we just provide a start and a stop. We'll just lead off with that, and we'll just print I. Because we're declaring 1 as our start, although indexes, as you know by now, start at 0, we're manually overriding that. Now, what we could do, let me come back up, hit enter to recall our statement, is just do this to start our index at 0 and come up to but not include our terminal or rightmost character. Now, we don't want to leave tuples out of the equation. We'll lead this off with a name that is officially a list, but it's a list of 3 tuples, isn't it? We'll then do for a, b in tuplist, print a, b. That gives us our tuples in a nice iterative fashion. First we grab index position 0, then we grab index position 1, and finally we grab index position 2. This next example might look a little arcane because it's going to involve an import and a call to a function that we haven't used before. I'm going to import the OS module, which is especially useful for those of you who are systems administrators and who are hoping to use Python as a way to develop administrative automation scripts. I'm going to declare 2 names here, K and V, in the OS module. I'm going to run the function environ.items. I showed you in an earlier nugget how to gather help and to access the module help in Python, so you're all set as far as on your own understanding more about the OS module. But basically what OS environ items does is it queries under the locally logged on user's identity environment variables from the system. So this will work on Linux and Windows. It won't work so well on Mac because the Mac OS X doesn't use the concept of environment variables. So we're dipping in and gathering through, or we're going to iterate through all of our environment variables here. And in our print statement, we're going to return to our friend string formatting using the C style, where we're going to do string equals string, and then connect with the %sign, and then pass in our variables, K, comma, V. That basically just gives us a dump of all of the environment variables that are relevant under the currently logged on user on, in this case, a Windows system. You'll see I've added a Python path variable, and then I've padded an equal sign, and then there's the variable, or the actual value. So that's what's going on with that. We're iterating through all of our environment variables. We're printing them one-to-one using simple string formatting. Nothing more complex than that. Our next example is again a little bit of a tease, something we'll be learning in an upcoming nugget working with files in the file system. I've created a very basic text file called spam.txt that I put just for grins in my C Python 31 directory. And as you see, there are not too many characters in this file. I'm not feeling particularly inventive this afternoon. I have 3 lines. This is the first line, this is the second line, this is the third line. And as I told you, in Python, the for loop is awfully useful for iterating through files and, for instance, reading lines out of that file. Excellent for administrative automation. So what we'll do here is declare a name called f, and I'm going to call the open function that's baked into the Python interpreter. And this opens a file from the file system and returns a stream of characters. So all we need by default, just at the very basic level, to attach a file handle to this file is, in a quoted string, the path to that file. Now note I'm using the / here because I don't want to start running into problems with the / and having to worry about escaping that. It's not a problem. You'll notice also this is a pretty cool feature of idle, that you not only get code complete for Python classes, functions, etc., but you'll notice it's actually giving me file system objects as well. It's detecting files in the root of my C drive, and I can just hit space now to complete that name. So I'll complete that path, and now that I've read that file into memory and bound it to a name called F, I will simply say for line in F, print each line. And there you have it. Now we want to make sure we're covering as many bases as possible. We don't want to leave dictionaries out of the party either. So here I'm creating a simple two-value dictionary. Well, actually, two-member dictionary. It's called NM, and we have two keys, key 1 and key 2, two values corresponding to those keys respectively, value 1 and value 2. Now we're going to declare K and V. Those are names declared on the fly, as you know. K for key, V for value. I guess I'm a little imaginative here. In, and check this out. And then you can call either iterItems in Python 2.x or items in Python 3.x to iterate through keys and or values in the given dictionary. I'm just going to grab everything, and then we're going to print K space V. Is this making some sense to you? Next, I want to give you an example of some embedded statements within a for loop. The way this works here is that we start with a list, and again, I want you always to be thinking in parallel, how can I actually develop something in business that accomplishes my goals using these things that I'm learning in the training? You can generate this list in so many different ways, it's crazy. In this elementary and academic example, our list I contains, as we've come to expect from strings, multiple types. We have string, integer, tuple, and float. How we get query data from the user, and within the application, again, the sky is the limit. In this simple example, I'm setting the name query to be just a simple lookup list that contains two items. And the way the for loop here is for key and query. Remember, key is our dynamic name that's actually our placeholder that iterates through, in this case, query. So we're taking what is presumably being asked for in our application, search engine, whatever. If key exists in our I, our set, our data set, then we print that key was found. Otherwise, if it's not found by default, the key is not found. So there's our embedded if clause inside our for loop. All right, let's see how this works. 5.6 was found, 3.14 was not found. Well, that makes sense, doesn't it? Given that the search was including 5.6 and 3.14 was not in the I set. Our final example before we move to while loops is something that should look kind of familiar, the multiplication table embedded for loop. We looked at this in an example earlier in the course when we were discussing other things, but I'm bringing it back to you in a slightly modified form, and I'm hoping it makes more sense to you this time. What's happening in this sample code is that the first for statement says for mult in range, and then we're hard coding the range. You'll remember in the earlier example, we used the input function to get the lower and upper bounds from the user. But here we're going to run 3 iterations, 4, 5, and 6. So we want to see 3 multiplication tables. 1 times 4, 2 times 4, 3 times 4, then 1 times 5, 2 times 5, etc. And then ultimately the same thing with 6. Now within that for loop, we're also running a second for loop that counts from 1 to 10. This is going to give us the other part of the multiplication table. In other words, each inner loop generates a single multiplication table. The print with no arguments simply is going to print a blank line in between each multiplication table. In this case, line 3 ties everything together because the actual physical output that the program gives to the runner is to print I, in other words 1 through 10, string literal x, which of course is the basic multiplication symbol in arithmetic, mult, which is our top counter, doing a table for 4, table for 5, table for 6, string literal equal, and then of course the product of I times mult. Let's run this one, and it works like a charm. We start with 4, and inner loop gives us 1 to 10, then we go to our upper loop 5, 1 to 10, upper loop 6, 1 to 10, with an empty print statement in between just to give us a little bit cleaner output. Let's now turn our attention to the while loop, the other of the 2 workhorse looping structures in Python. Let's dive right into the code here. Whereas for is going to iterate through a finite sequence, dollars to donuts, while is more of a continual evaluation. That is to say, you open up your while loop with some test that must evaluate to Boolean true in order to continue. I'm going to show you, for instance, a numbers guessing game where we might say while guesses is less than 6. So you'd get 5 guesses, otherwise you'll abort the while loop and perhaps terminate the program, you see? Therefore, while is a more longer running loop construct in most cases. Now, indented underneath the while header line, we have our indented statement block. This is going to be our true code, our true case code. And depending upon how you handle that true case code, you can use break and continue to give yourself more flexibility. Many times, while loops are used in a faux for way, if that makes any sense, where we might set in this guessing game guesses equal to 0 initially, and then while guesses is less than 6, we can say prompt the user to guess the number that we've randomly created, and then increment the guess value and continue, for instance, to send the code up to the while condition again, hence the loop. Now, the else clause is optional in a while loop, and it works a little bit differently from, say, how else works in an if statement. Here, else runs every time in the absence of a break. In other words, while your test is true, you're doing your statement block. As soon as test evaluates to false, in our guessing game example, once the user unsuccessfully does his or her 5th attempt, the else code runs. The only way to actually break out of this entire while block is to use the break command, which I've introduced you to already. The thing we want to be careful of with the while loop in particular is that while loops can result in an infinite loop. Especially, I mentioned this in the previous nugget as being kind of a hacky approach to using the while loop. You could open up your while loop with while true, and now there you're not really doing much of a test, are you? As long as your indented code evaluates to true, this loop is going to run forever. So you want to strictly control your conditions such that you do have a false case, and or you've got a break to get yourself out of that block. You want to avoid infinite loop problems for obvious reasons. To dive into the code, why don't we start in the Python shell by creating an infinite loop condition. I'm going to say while true, which again can be a slippery slope. Some Python programmers don't like this at all. They think that you should have a much more narrowly defined true condition. But I'll open this up and simply print a string literal. Now this is going to be a little funny to those of you who remember the original basic programming language. The very first basic program I learned was 10 print and then some string, hello world, right? Line 20, go to 10, and then you would just have an infinite loop of the print statement forever and a day. Well, guess what happens here? A very similar construct. Now, if you've ever had this happen in a terminal shell, you can abort out of an infinite loop by using the Control-C key sequence, but we certainly do not want to do this in our production application. Let's get a little more sophisticated now. I'm going to declare a name called X and set that guy at 0. We're going to create a Y name, set that at 13. Now I'm going to say while X is less than Y, not equal to Y, but less than Y, colon, we're going to print the value of X. Check this out though. In order to bring us back to the top of the loop and actually give us some work, we're going to use incrementation. Now I could say X equals X plus 1, but I tend to prefer the more compact shorthand notation, plus equals 1, which tells Python interpreter to print the value of X, increment X by 1, and then return to the top of the loop. So the first pass through this while loop, X is going to have what value? It's going to have 0, right? Because we've defined it here. When we get to this third line of the while statement, X will now have a value of 1. So eventually the condition is going to happen where X is not less than Y, and that's our terminal condition. Now we could explicitly handle that with an else statement, otherwise the program is just going to terminate. So let me hit enter a couple times and we'll see what happens. Sure enough, we go from 0 to 12 and then the program stops. Our next example, I'm running this from a script file. Let me save my work. We're setting an initial value for A of 0, and here the while condition says while A is less than 13. We know that the maximum allowed value for A now is 12, don't we? And all this while is doing is first going to increment A each pass through. So the first pass through, 0 plus 1 is 1. And then notice that we have multiple ifs. Note that this is not elif. In this simple case, I'm just saying increment A, and then if A is equal to 5, continue, in other words, go back up to the top of the loop. When A hits 10, break. And we're going to break completely out of the while loop. And then we want to see something on our screen, so we're simply going to print the value of A. So to walk through this on screen, at first run, 0 is going to hit this line and become 1. It's not going to qualify for this if statement, so we go down to the next if statement. It's not going to qualify for that if statement, so we print the value of A and come on back up to the loop. Now we've got 1, and then 2, and then 3, and so forth. So we can finish this by running the module, and you should see 1, 2, 3, 4, 6, 7, 8, 9. So we skipped 5, and we ended at 9. Just because I don't expect you to have a photographic memory, let me come back to that script file. This continue statement aborts the print because continue tells the code to immediately do not pass go, do not collect $200, come back up to the while. You see? That's why 5 was not echoed in our output. And the reason why 10 wasn't echoed is because when we got to this line, when A had the value of 10, we executed this code, which was using the break statement to pull us out of the loop in toto. The very final example I want to show you is the longest script file we've seen thus far. If we read my documentation string, this is a guess the numbers game. It's adapted from some code you can find on the web, inventwithpython.com. We need to include our attribution here, of course. The purpose of this program is to demo a live Python program. I simply want to take a lot of the things we've learned thus far in the course and put them into a real Python program. So instead of just the toy code, we're seeing how some of this works. Now, if by the time we finish looking at this module, you understand everything in it, you should really congratulate yourself, give yourself a hearty pat on the back. I would do it if we were physically together, because I think you've really come a long way in understanding how to use and apply Python. Alright, so the code proper starts with an import, one of my favorite modules, the pseudo-random number generator, the random module. And we're creating a name called guessesTaken and setting it or initializing it at 0. Next, we're going to present to the user, hello, what is your name? Now, I'm accustomed to combining the input and the print statement together. In other words, just using the input statement with this as the prompt. But this is useful because it shows you another way to do it. We're just printing a string literal and then giving the user opportunity to enter his or her name. That gets captured in the name, my name. Next, this procedural program generates a pseudo-random integer between these bounds, 1 and 20. We bind that to a name called number, and then we come back with a statement, a personalized statement, well, my name, and we're using concatenation here. The plus sign is used for string concatenation, but thus far I've really been using the comma, which does the same thing. So if I put my name as Tim, it'll say, well, Tim, I am thinking of a number between 1 and 20. It's just giving us that text. Here comes the meat and potatoes, our while loop. While guessesTaken is less than 6, so we get how many tries? 5. The user is prompted to take a guess. The input function gathers that guess, and then the int function converts that string, which is going to be a decimal, isn't it, to an integer. We then increment guessesTaken, because each pass through this while loop, we want to count against the maximum of 6 that's at the head of the loop. Then we have our if conditions. If the guess is less than the number, we print your guess is too low, return to the top of the loop. If guess is greater than the number, the guess is too high. If the guess is the number, if we're correct, then we break. And remember, break basically takes you all the way to the leftmost first column in the script file at the same level of outdent as our while. We're out of the while loop now. If guess equals the number, then we create another name that takes the number of guesses, converts it to a string for display. Remember to display information for the user. In this case, we're going to want a string value. We then print good job, personalized name. You guessed my number in so many guesses. If the guess does not equal the number, so once we've broken out of the while, the two ways we can break out of the while, of course, would be 1, if we guess the correct number, or 2, the initial while statement evaluates to false. In other words, we've consumed 5 guesses. So either way, we then hit these bottom if statements where either you've correctly guessed the number or you haven't, and you get a prompt depending upon which of those paths you've taken. This is an excellent piece of code, I think, that wraps up what we've learned thus far in the course. Let's actually run the module. Hello, what is your name? I'm going to say Tim. Gives us our personalized feedback. Take a guess. It's between 1 and 20. I'll just say 8. Guess is too high. How about 5? I guessed it in 2 guesses. Cool. Control flow, part 2 of 2 review. I hope at this point you're feeling much more comfortable with using and applying Python. By this time, now that we've covered for loops and while loops in this nugget, the if statement in the previous nugget along with Boolean logic, we're in a really great spot to develop more and more complex Python applications. Of course, remember that Python is designed as a simple, elegant, and intuitive language, and needless complexity is definitely not worth it. Remember what it says in the Zen of Python, after all. I hope that this has been informative for you, and I'd like to thank you for viewing.